All right, let's dive into a part of your devices that honestly holds their very soul. Read-only memory, or ROM. This is the memory that's built not to forget. And its story, well, it's a wild ride from a simple, stubborn chip to the absolute powerhouse you've got in your pocket right now.
Have you ever really thought about that? You turn your phone on and poof, it just knows how to be a phone. But how? The power's been off, maybe for hours. Where are those basic fundamental instructions hiding? How does it remember its own identity from a cold start?
Well, that little bit of magic comes down to a very special kind of digital storage. It's the permanent foundation our devices are built on. So let's get right to the heart of what it is.
Okay, a couple of key phrases to lock in here are non-volatile and permanent instructions. Now, non-volatile sounds complicated, but all it really means is that the data doesn't just disappear when you cut the power. And that makes it the perfect place to store the unchangeable rules a device needs to boot up and function. You see, it's this combo of being non-volatile and read-only that makes ROMs so unbelievably reliable. I mean, think about it. You literally can't accidentally delete your computer's startup instructions. Now, sure, it's slower than its flashier cousin, RAM, but that's a trade-off you want. For this job, stability is everything.
But here's the really interesting part. ROM isn't just one thing. Oh no, it's a whole family of technologies, and each new generation was basically invented to solve a problem that the last one created. This is a story of evolution, one brilliant fix at a time.
So let's start at the very beginning, with the granddaddy of them all, mask ROM, or MROM. The easiest way to think about this is like a book. Not one you write in, but one that comes from a printing press already finished. The text is set in stone, and it can never, ever be changed. With MROM, the data is physically baked into the chip's design when it's made in the factory. Now, this process is super cheap if you're making millions of them, which is why it was perfect for things like your old school calculator or one of those toys that plays the same song over and over. Their job was never, ever going to change. And right away, you see the problem, right? This is great if you're a huge company churning out a million identical calculators. But what if you're a developer? What if you're prototyping something new? Or you only need a few hundred chips with your code on them? You needed a way to write the instructions yourself. And that led to this, programmable ROM, or PROM. This was the answer. It's kind of like getting a blank CDR back in the day. The chip arrives as a totally clean slate, and you, the user, get to be the one to burn your data onto it.
But, oh boy, there was a catch. And it was a big one. You could only write to it once. One single mistake, one typo in your code, and that little chip was toast. A tiny, completely useless piece of silicon. You had to just toss it in the bin and start all over. Talk about high-stakes programming.
You can imagine how frustrating that was. And that exact frustration drove the next great innovation. All that waste, all that pressure of getting it perfect the first time, it just wasn't sustainable. Engineers desperately needed an undo button.
And they found one. The breakthrough was called Erasable Programmable ROM, or EPROM. And this was like switching from using a permanent marker to a whiteboard. For the first time ever, you could actually wipe the slate clean and start over. The solution they came up with is just wonderfully nerdy. See that little window on top of the chip? To erase an EPROM, you had to literally blast it with intense ultraviolet light through that quartz window. The only quirk? The UV light erased the entire chip, not just your one little mistake. Still, this was a massive deal. It meant developers could finally experiment and fix bugs without going broke. So as you can probably guess, having to physically pull the chip out of the circuit board, stick it in a special UV eraser box, wait, and then plug it back in, well, it was a pain. It was slow and clumsy. The next logical question was, can't we just do this with electricity? And that brings us to EPROM, Electrically Erasable Programmable ROM. And this is where things start to feel a lot more familiar, a lot more modern.
This was a total game changer. Not only could you erase the chip with a simple electrical pulse while it was still in the device, but you could erase and rewrite tiny, specific parts of the data, byte by byte. That level of precision and convenience is exactly why EPROM became the go-to for things like your computer's BIOS, which needs to be updated every now and then.
Okay, and now we get to it, the final and by far the most important leap in this entire story. This is the version of ROM that is, without a doubt, powering the device you're watching this on right now.
Meet flash memory. Now, at its core, it's really just a type of EEPROM, but it has one killer improvement. Instead of rewriting data one single byte at a time, it does it in big chunks called blocks. And that one change in strategy, working in blocks instead of bytes, made it so much faster and more efficient that it completely changed the world.
And here's the big reveal. This is where it all connects back to you. That fast, efficient, rewritable memory is flash, and it is in everything. Your smartphone's storage, that's flash. Your USB thumb drive, flash. The solid-state drive in your laptop, yep, that's flash too. All of it is the direct descendant of that first unchangeable little chip.
So that was quite a trip, right? From a circuit that was basically set in concrete to the super flexible memory in our pockets. Let's just pull back for a second and look at the whole family tree at once.
You can see the whole story laid out so clearly here. We start with MROM and PROM, where erasing was just not a thing. Then EEPROM comes along and says, yes, you can erase, but you need this weird UV light. And finally, EEPROM and Flash bring us into the modern age with electrical erasing. Each step solved a huge problem, making memory more and more powerful.
I mean, this is it, right here. We went from a memory that was fundamentally unchangeable, physically etched at a factory, to one that we rewrite millions of times a day with our photos, our apps, our whole digital lives. The unchanging memory finally learned how to change.
And that leaves us with one last kind of funny question to chew on. If the read-only memory in our phones is now one of the parts we write to most often, does the name even make sense anymore? It's really just a ghost of its own history, isn't it? Something to think about. Thanks for exploring this with